For me, climate change is one of the great challenges of the 21st century. In my view, we have four major challenges that we have to face in this century. Firstly, of course, climate change, which I'll explain a little bit more later on, but we also have to think about global poverty and the number of poor people who don't have access to food or clean water in the world. We also have to think about environmental degradation, because we're actually destroying the planet at the same time as we're changing the climate. And the last one is then global security. We have to actually look at all these to see how we can actually change the way we work, change the way we do industry, and change how we do some international politics to make sure in this century we can actually cure all of those. For me, climate change is at the nexus, the center of this. The problem is that since the Industrial Revolution, we've been burning fossil fuels. Now, don't get me wrong, fossil fuels are fantastic. They have produced a brilliant industrial lifestyle. They produce cheap energy. They've been able to allow us to make sure that water is clean, food is freely available, but it has a side effect. When we burn fossil fuels, they release greenhouse gases. Things such as carbon dioxide and methane, nitrous oxides and CFCs. And these have an unintended consequence. They're warming the atmosphere. So if we look at the atmosphere, climate change is really just simple physics. So at the moment, the sun shines on us and the light energy from the sun passes through the atmosphere, almost as if the atmosphere isn't there. All of it passes through, except a small amount, which is the ultraviolet radiation, gets absorbed by the ozone layer, which is fantastic because, of course, we all know that ultraviolet radiation causes skin cancer, can also do DNA damage. So it's great that we're protected by ozone. But most of the energy passes through, and some of it hits the snow cover, the clouds, and all the white surfaces and the light surfaces and get reflected back into space. So a third of all the sun's energy goes straight back into space without actually hitting the ground. And then the other 2/3 hits the ground and converts. We all know this because we've all lain out by a swimming pool on a lovely hot summer's day, and the sun's energies hit us and we feel hot because the solar energy is converting to heat and then radiating off our bodies. And the same happens to the Earth. Now that heat radiates off of the Earth, and this is where the greenhouse gases come in. The water vapor, the CO2 and the methane capture a little bit of this heat and hold on to it for a little while and then release it, which actually keeps our planet nice and warm. If we stripped out all the greenhouse gases, we took out water vapor, CO2 and methane from the atmosphere and took it all out, the temperature of the Earth would drop by about 35 degrees Celsius. That would mean the average temperature in the tropics would be -15, too cold to actually produce food or for us to actually survive in a proper, nice way. So greenhouse gases have kept the world nice and habitable, but the problem is we're putting some extra in there. And we've been doing this since the beginning of the Industrial Revolution. And so what's happened is that by burning fossil fuels in our cars, in our power stations, and also by changing the way we use the land, and we're basically cutting down forests, changing land into agricultural land, we're releasing more of those gases. And that has started to warm up the planet. So we know that over the last 100 years, we've increased carbon dioxide by about 40%, and we've doubled methane. And that has led to a temperature change of nearly 1 degree Fahrenheit, which is actually quite a significant warming. And that is why we're worried about climate change, because it changes the rules on which our planet climate is based. One of the interesting things about our carbon pollution, particularly carbon dioxide and methane, is that not all of it is ending up in the atmosphere. We've been very fortunate that for every ton of carbon dioxide we pump into the atmosphere, half of that is being taken out by the planet. Now, a quarter is going into the oceans. So the oceans are absorbing the CO2 and, unfortunately, acidifying. So despite the oceans helping us with the pollution, it's also acidifying and causing problems for corals and for other small organisms that build calcium carbonate shells. The other quarter is being absorbed by the land biosphere, mainly the forests, particularly in the boreal and high latitude areas and in the tropical rainforests. Now, the things that scientists are worried about is, of course, that's great, but at some point, the oceans, because they're warming up, can hold less gases, and particularly less CO2, so they may start to hold less gas and therefore start to take up less of our pollution. And also, if we look at the biosphere, we all know that, of course, we are constantly cutting down rainforest for actually agriculture. We're changing sort of forests around the world, in North America and in Europe. And so therefore, the actual propensity for that biosphere to actually absorb carbon dioxide is reducing every year. So we cannot rely on that. So one thing scientists are worried about is we have to actually cut our carbon emissions and drop it down rapidly over the next few years, but we also need to be worried about whether nature is still going to be absorbing some of our pollution. Scientists are also worried about what we call positive feedbacks. So one of the problems is that we're worried about the Arctic sea ice retreating, and we know that 2008 and 2012 were some of the most extreme retreats of sea ice that we've seen in the Arctic Ocean since records began. The problem there is that, of course, white sea ice reflects sunlight into the atmosphere. Now, of course, if you have dark ocean instead of sea ice, then what happens is more heat is absorbed. And we call this the Arctic amplification. So when we're predicting the future of climate change, the interesting thing and worrying thing is the Arctic and the Antarctic seem to warm up twice as much as the tropics because of these positive feedbacks. One of the consequences of climate change is that the planet is warming up. But that also warms up the oceans. And of course, we all know if you heat up a liquid, it expands. And so we are worried about sea level rise because we've already documented that over the last 100 years, the average sea level of the whole globe has increased by about 25 centimeters. Now that may not sound very much, but if you think about it, that allows storm surges to be slightly higher and slightly more extreme. What we're looking at into the future is more thermal expansion of the ocean because of this heating up, and also because Antarctica and Greenland are starting to melt, more water is being added into the oceans. Now there is one thing that is least worrying about sea level change is it is very slow. So at the moment we're thinking that sea level change is about 3 millimeters per year, which is incredibly small. But of course over a decade, over 2 decades, over 50 years, if that starts to accelerate, it will have a huge effect. So we can see that perhaps by the end of this century, we're looking at a meter rise in sea level, which is going to have a profound influence on coastlines, whether it is protecting coastlines, eroding coastlines. And the other problem is, of course, many of the storms that we're worried about, whether it's winter storms or hurricanes, the storm surge that's created, if the baseline is already a meter higher than it was, then we're going to have a more devastation inland because of that. But the key thing about sea level rise is we'll be able to see it coming because we can measure it and we can start to see when it accelerates. There is not going to be this massive sudden change as the Hollywood movies show that suddenly over 5 years we're going to get a meter. No, but it's a long-term problem that we will see it coming, but we'll need to plan for it and actually protect our people from that rise.